this morning is quite full of a lot of interesting topics for me, and I guess also for you. And so I would like just to leave the floor for the first section to the Vice Mayor of Bari. I just changed a little bit the agenda due to the to accept the different task commitment of the persons. With Bari, DTA is working to develop several initiatives to support urban air mobility. So please, Mr. Di Sciascio is the Vice Mayor of the city. Please.
Hi, good morning to everybody. I'm Eugenio Di Sciascio. I'm the Vice Mayor of the city, and actually in real life, as I used to say, I'm a professor at this Polytechnic University, and I'm also the former president of the university. So somehow I think to play at home. But in my role as Vice Mayor, I'm happy to welcome you all today in the city. I hope, as Antonio said, that you are enjoying the stay here. We try to have a good weather for you, or at least the weather was fine in these days. And I just want to take a minute to say that Bari, the city of Bari, is deeply involved in the themes you are working on, because we believe that innovation is the key to the development of a city. And in the framework of urban air mobility, we are working basically through some projects, some European projects, but also in the framework of the so-called House of the Casa delle Tecnologie Emergenti, House of the Emerging Technologies, which is a project financed by the Ministry for Economic Development, and which has co-partners, the DTA, the Polytechnic University of Bari, and several stakeholders of the territory and beyond. And we're working also on the seamless integration of urban air mobility with autonomous vehicles, and we have a test ground in the fair, in the Levante Fair, which is a large, small city. Large fair, but it's a small city, and we're using that to experience a series of activities. We have been busy setting up an infrastructure to monitor also these activities. Today we have, for example, an autonomous vehicle that is testing around in the framework of the fair, and we also are happy to announce that we also will be hosting in October Drones Beyond, which is an important initiative carried out with the DTA in collaboration with our administration. I won't take any more time, and again, thank you for being here, and good work for this day. Thanks.
Thank you, Mr. Di Sciascio. Now I would like to have introduction to the Dean of Polytechnic of Bari, Mr. Cupertino, which is hosting these events, and thank you for having accepted this event to be in the Polytechnic of Bari.
Thank you. Thank you, Antonio. Just welcome here at Politecnico di Bari. It's a pleasure for us to host this event of this project. I also hope you are enjoying your staying here in the Apulia region. We a little, we used to stress the attention on the value of being in a place where it's good to live, but what I want you to take with you after this event is that Apulia is also a good place to make research, to have collaboration. We have good universities, good infrastructures. In particular, Politecnico di Bari has been involved in the field of aerospace research, in the field of manned aerial vehicle for the last 10-15 years. And I hope that also this kind of involvement will help in the next future to have the cooperation of our students, our researchers. We are trying to push our students to come closer to the field of aerospace research to understand which could be the opportunity that this field will offer to them for the activity remaining here in Puglia and having the opportunity to have a wide range of international cooperation. I think that we need talents in all our research field. I was personally involved in the field of aeronautic research before having this duty of being rector of my university, and I understand that we need new talents. We need to let people know what we are doing, which could be the value of the results of our research for the companies, for the public entities that, for the rulers that operates in our territories. And so I leave the floor to the technical content. Again, I hope you enjoy your staying here at Politecnico di Bari and enjoy this open day today. Okay, thank you all.
Thank you, Mr. Cupertino. Indeed, you opened an important topic about the talents of the young students, young researchers, and how relevant they are for this industry. Thank you. Now I would like to leave the floor to Mr. Acerno, which is the president of Distretto Tecnologico Aerospaziale. That is the company that inside the project coordinated and organized the demonstrations. Please.
So first of all, thank you to everyone for your coming here. We are really happy to join this event with you. Part of you gave a relevant contribution to the result that we have achieved. From our point of view, staying here is not only a pleasure, but it's only the aim to testify how important for us is to give a contribution to this European community that is working so hard in order to introduce these new technologies in our life, and I would say in the life of everyone. We would like to testify how we do it, not only with the CORUS, but with activities that in this year we have made in order to create consensus and also to create the condition in which the institutions can find in the coming of these new technologies, new opportunities for their communities. So on top of the agenda in this region, since almost 15 years, aerospace is there. And this is the first result that we think it's important to have a framework in which we could operate. But apart from this, I would say that the relations with the universities, you have already heard from the voice of the rector, which is the impact of these technologies on their path. I would say that the relation with them have given us the possibility to make many activities in terms of research and development. We do it with our shareholders, which are mostly enterprises belonging to the aerospace sector. Some of them have participated also to these activities, and with particular stress on the infrastructure, on which we are investing a lot in the last few years, starting from the Grottaglie airport, which is the place in which we have already invested in order to have technological capabilities to give support to the activities or development of these new technologies, in which we are soon going again on with almost 12 million euros of investments to increase these technological capabilities. We do it because we believe in the importance of innovation in general, but in particular of these technologies for the improvement of our life. And we do it because we think that we operate in a comfortable situation in a network like this. And we do it in order to give to this region and to our community the opportunity to find new chances in terms of jobs and revenues. So this is probably the most important reason for what we day by day try to conduct and to drive the activities that can push ahead the level of technologies and innovation of this region, and I would say of the aerospace Italian community. Thank you.
Thank you. And now the last speech from Mr. Casalegno, Head of Innovation Sustainability in ENAV. Please, the floor is yours.
Hello, welcome and greetings to everyone. I'm Stefano Casalegno, ENAV. We are very proud and happy to present today here and be part of this extraordinary group of partners. I've penciled up 3 numbers to introduce you the day: 40, 23,000, and 7.4 million. 40 is 1982, 2022. It's Blade Runner. My generation have seen this movie, and we have imagined the U-space at that time. It was a gray sky, it was very polluted, if you remember that. It was amazing to imagine how the sky would look like in future. Well, today here we are trying to make this sky much more greener, much more sustainable. We have to produce a U-space which is sustainable. Sustainability is at the core of the industrial plan for ENAV, together with innovation. So for achieving the construction of U-space, we have together to work to construct together a sky and a mobility that will be sustainable. The second and third numbers that I penciled up, it was 23,000 and 7.4 million. That is the expectation of the urban air mobility flying in 2035, 23,000 engines, and about 7.4 million engines flying in Europe in 2050. So our expectation is to have a continuous progress in this technology and a continuously increasing populated U-space, which needs to be integrated with the rest of the classical aerospace sector. So for doing so, in ENAV we are investing in, of course, European projects like this one. We are also investing in other co-finance projects. We have an R&D department dedicated to these activities. And we believe the keys of success of such a new coming new space is collaboration, is partnership, is stakeholder engagement. We need to continuously accumulate innovation together and within an ecosystem of partners such as the one that are today here with us, construct together, imagine a future, test, and construct it progressively this new technology that will habilitate, that will allow the U-space to be real. So again, greetings to everyone. I welcome the activities of today. I'm really looking forward to hear more about the presentation today. It will be amazing for everyone to hear about the Italian cluster of CORUS-XUAM, what I've done, and then eventually to integrate our activity with the other European partners from the same project. Thank you.
Thank you, Mr. Casalegno. Thank you. And now let's start on the second topic, second section. It is about the UM development process and works in Italy and Europe. And so we would like to have we will have some discussions about the main technological challenge. Let me start with Mr. Ferrara, which is also the project manager of CORUS-XUAM project. Yeah, you can speak. Oui.
good morning to everybody. Let's put it in presentation mode. I guess you can see because I cannot have a feedback. No?
No?
Okay, let's, I don't know how we can manage that. You know better than me. Probably you can push here. Let's see. Okay. It's back? Okay, thank you. So, good morning again to everyone. As Antonio was introducing me, I'm Giancarlo Ferrara. I'm from Eurocontrol, former ENAV when I was an executive in the Italian Agency for Air Navigation Service Provider. Then I moved to Eurocontrol, and currently I'm coordinating the CORUS-XUAM project and mainly managing all the R&D activities that are dealing with U-space and drones in Eurocontrol. So I will provide you with a very short, let's say, overview of the project, just to give you a bit of background for the people that are not fully aware of that. And so let's start immediately, saying that as you probably already know, and you have seen probably in the flyer you were getting, CORUS-XUAM is a European project that has been funded and supported by CESAR Joint Undertaking, and we will hear later from Cengiz some word about that. And the main objective was to perform 6 very large-scale demonstrations, but of course was not only the objective to conduct very large-scale demonstration, as we will see later, and we are doing that in 7 European countries. I will provide you more details later. But the main focus was on the demonstration of safe integration of a variety of urban air mobility missions, mainly enabled by U-space services. That, as you know, will be a sort of a digital environment we are trying to build in Europe to manage this type of operations. Of course, the demonstrations were looking at, let's say, the more mature and validated operational U-space concept and services we were developing so far with previous projects. And the main project that was starting to sketch a bit what is the reference framework was CORUS project. So it was, again, funded by CESAR Joint Undertaking and made by several partners that are also now in CORUS-XUAM, and it was in 2017 up to 2019. So building on the results of this project, mainly CORUS-XUAM was trying to expand, let's say, the services required for supporting and enabling the urban air mobility operations. This is more or less the objective at high level. Let's see, to move forward. Just a few words about the consortium that is working on this project. It's composed by 19 international partners that are having different expertise and are bringing different type of know-how on board. We are starting and we are lasting from air navigation service providers. We are passing through the U-space service providers, and we have also a lot of research entities that are working on the subject. But some of them that are also, let's say, are also US operators and also urban air mobility manufacturer in terms of aircraft and eVTOL. It's not only the consortium, of course. We were trying to extend as much as possible the participation of our stakeholders in the project to get the concept of operations that we are defining accepted by the community. And so we were organizing several, large advisory board with several partners. And then we have also a community network that we were building. Of course, there were several participants there as well. And generally, we are using these fora to present the results and to get feedback and to refine what we are proposing for the way forward. And for that, we have already organized 2 large workshops in the past few months, and there will be another one that we will organize together with CESAR Joint Undertaking in April next year. So stay tuned, let's say, and you will get further results. A few words about, let's move forward. Yeah, a few words about the high-level objectives we are having. As I said, more or less, we are working on the operational U-space concept and services. So we are trying to consolidate what we already did in the past, looking at the new users that are coming, that are mainly, again, urban air mobility operators, providing services for cargo and also for passenger transport. And we are also refining the U-space services and solutions that so far were already tested in previous projects. And as I said, we were also extending the U-space concept of operations, mainly looking at urban air mobility, but also looking at the airborne capabilities that will be available in the new type of aircraft we will get on the market. As I said, these activities not only dealing with let's say CONOPS, let's say with the very large-scale demonstration to be performed, but also to further develop what is the concept of operations and mainly the services that we are using. And of course, for doing that, we are mainly trying to build this picture also in relation to the other projects that are working on the subject. So Eurocontrol and CESAR joint undertaking through CORUS-XUAM, we're building a sort of a task force that is called U-space CONOPS Coordination Cell that is working with the other 17 CESAR joint undertaking projects and is trying to collect and integrate all the results in a single concept of operations that will be delivered to the community by mid of next year. Few words, as I said, it's not only demo activities that we are conducting in CORUS-XUAM, but we have also a theoretical work that is going to be performed, and we were building on the U-space CONOPS Edition 3. Again, I don't want to bother too much on the, on the details, but these are the two main pillars that we have in the project. A few words about the structure, apart the coordination and management activities and the communication activities. We have several work packages that we're looking at definition of operational environment and requirements, that is work package 3, and we're also addressing what are the needs for from a societal perspective. And there was the work package 4 that was working on the consolidation of CONOPS, and we were having the work package 5 that was a sort of orchestrator of all the demonstration activities, mainly preparing the validation plan and also getting the result to prepare the final validation report that will be shared with the others. And then in yellow you will see at the center all the activities we have in several places. Few words about that. These are the main activities in terms of demonstrations that we were planning, and we are let's say further planning by the end of the year, until the end of the year. So we had one demonstration that was in Spain, was the first one that was dealing with the urban environment and urban operations. It was made in Barcelona in April 2022. And then we had the one that we are presenting today, that is the work package 8, made by, let's say, led by the Italian companies, where we were having some demonstration activities performed in Taranto, Grottaglie, and it was June 2022. We will have further activities that will be conducted very soon in Sweden, where there will be a sort of shuttle service organized between two cities, Linköping and Norrköping, and there is an open day organized there as well in Norrköping on the 6th and 7th of October. Further information are available on the website, of course. In the next, let's say, week, we have also France that is doing a large demonstration activity with some of the eVTOL manufacturer we have here in the room as well, and is in Paris Pontoise Airport, and this will be on the we will start on the 21st of September, and we will have an open day that is going to be performed on the 23rd of September. Of course, you are invited as well in case you want. You can register on the website that I will provide you later. Few words about the demonstration we had in Spain. Was a last mile delivery, as I said, in the urban environment. I don't want to provide you so much details, but it was really close to the city. There were several vertiports organized, and there were sort of a demonstration that was proving that the feasibility of the last mile delivery while operating in an urban environment, and we were also operating close to an airport. As you know, Barcelona airport, as you can see in the picture on top, on the right, it was not so far from Casteldefels, and there were special, let's say, clearances and also authorization that we were getting in terms of following the airspace assessment and so on, that was mainly made by Enaire and partners that were participating to this demonstration. I don't want to bother you with the Italian demonstration because I guess Giovanni will provide you more details later, so we can skip this slide, but just to say that it's mainly looking at medical supply. Further information will be provided by Giovanni. Few words, and this is the last slide I have, few words about the stakeholders' involvement. As I said, we are having a large advisory board, and generally we are communicating with them, and we're getting feedback on what we propose for the way forward, as well as we have also contact with the national civil aviation authorities, as well as with other U-space related projects. And we are also trying to link, in terms of standardization activity, with external bodies like Aerotre and so on. Of course, EASA is fully involved. We are, let's say, keeping them updated in coordination with CESAR joint undertaking. And this is, let's say, explaining how we are trying to exploit as much as possible the results coming from the project. Few words just about the partners. You see here the partnership we have. It's starting from Eurocontrol that is coordinating, but it's going through several actors you will see here. As I said, further information will be available. You can find it on the website. You can see here the address. And if you have additional questions, I would be really happy to answer. Thank you very much, and enjoy the rest of the meeting.
Thank you, Giancarlo. Thank you for this presentation of the project, and also we understand now how relevant it was for us to be inside this European project and sharing the experience we realized in Italy and in Grottaglie with other experience realized elsewhere in Europe. And also this project was useful also for Italian system, not only for the partners of the project, in particular for the Italian Civil Aviation Authority, because a part of this, the activity we realized was realized through an authorization to US operation, and indeed today we have also introduction to the strategy of the INAC, Italian Civil Aviation Authority, provided by Mr. Riccardo De Lise. Please.
L'ultima. Avanzare. Oh, okay. Good morning to everybody. I'm Riccardo De Lise, Process Management US and Advanced Air Mobility of INAC, Italian Civil Aviation Authority. It's a pleasure for me to attend this meeting, and I thank you, the organizers. I will present the principles of INAC Italian Strategic Plan for Advanced Air Mobility and relevant news. First of all, there are three main items. Taking into account the challenges and opportunities offered by new raising technologies of the operations by drone, the objectives of the raising technology challenges of the strategic plan can be summarized in these three important items. The first one is the creation of an Italian ecosystem for AM, with a holistic approach to services. That means a set of innovative intermodal air transportation of goods and peoples and service, mainly carried out with unmanned system and manned system. A critical element of advanced air mobility is the infrastructures, which supports and makes possible safe and secure operation to achieve the goal of enhanced accessibility of cities and territories, and obviously improved quality of life for citizens and a clear environment. The second item is Italian strategic plan issued by the stakeholders, and the third item is the identification of specific steps to accelerate. First of all, the basic elements of the definition are a safe and secure intermodal transportation network of services. We are talking about moving goods and people, and also aerial job, and also emergency services. Never before seen. This system will change people's lives for the better, because we're going to use the most advanced technologies, which involve manned and unmanned electrical vehicles with low impact on environment. Finally, infrastructure is a key element of EM. In this slide, there are the four main elements to allow AM. The first is sustainability. That means reducing local emissions by introducing mobility solutions and services with a smaller environment footprint. The second is quality of life. The third is generate value for the country. That means developing services based on innovative technologies will create opportunities utilizing skills which are transferable to other sectors. The fourth is element considering the inclusive mobility as service solutions. That means a digitally integrated platform which provides the best solution to move people or goods to various locations through intermodal and multi-domain modes. Just in summary, on the left, on the right side of the slide, there are the 4 steps: reduce travel time, connecting communities, digitalization, and a modern mobility, which ensure a new generations of system and services. In this slide, there are the 4 concepts of users application that has been identified to be included in the roadmap, in the ENAC roadmap. CORUS-XUAM demonstration among them included goods and vehicle delivery testing in the legs from Grottaglie Airport and Manduria Aerotre Airfield, and from Manduria Airfield 3 to Manduria Giannuzzi Hospital. This the last leg, Italian operator TechnoSky using Italian manufactured drone produced by Nimbus. In this slide, we have the 6 competencies groups activated to cover the following AM framework main components. The first one was safety perception. That means privacy, jobs, environment, noise, and also visual disruption of the drone, because this is unusual. The second one was the U-space integration. For that, please consider that in the CORUS project, we have the important contribution of Eurocontrol, INAV, and the flight. Third, we have in CORUS the contribution of Italian and foreign manufacturer. At point 4, individual vehicle management, it is including the aspect of risklessness beyond the visual line of sight operations, and also the future autonomous flights. Fifth point, air traffic and fleet operations, and last but not least, the 6th point is the important business model, the economical and financial perspectives. In this slide, there is the EASA roadmap in order to show you that Italian point of view, Italian action, Italian projects are fully consistent with European project issued by EASA from the rulemaking task and UAM task force. In this slide, we can see the important time schedule, for example, 2024 and 2023 for vertiport regulation, 2025 for it is scheduled the electrical vertical takeoff and landing transport of people, and in 2030, 2035 the international cargo. We mean international intercontinental cargo. And it is important to say that the investment is really high. It is expected by 2035, 17 billions of dollars. What are the following steps to accelerate? First of all, there are the memorandum of understanding with the regions. among INAC and the regions. At the moment, today we have 5 memorandum, but we are developing and we are inviting the regions, other regions to cooperate in this project. Then we have a memorandum of understanding with the cities in order to allow the development of this sector. And also we support local authorities in detecting their mobility needs in air taxi, delivery of goods, not only with the commercial purpose, but also with emergency, for example, the biomedical transport. In addition, inspection, the mapping of infrastructure and agricultural support. In addition, there are important public acceptance initiatives that have been promoted. And a working group has been established to define the guidelines to update the local transportation and the SAMPs, that are Sustainable Urban Mobility Plan. With reference to the support to public institutions, there is an important general director letter that was signed on July. It contains indication to them when they want to commission beyond the visual line of sight drone operation an external drone operator. This is a very common situation where the public institutions want to use external operators, external enterprise, in order to externalize their project and their services. As you know, several institutions would like to use this technology with external operators, and it is important for them to know how to proceed. These indications arise on the basis of our last 2 years' experience. The first, there are 2 fundamental messages given in this letter, and are highlighted in yellow box of this and the following slide. The first one is to coordinate with ENAC well in advance an appropriate roadmap in order to discuss the preliminary feasibility. Sometimes the project is too aggressive, it is not possible with today's technologies. Sometimes there is no clear vision of the possibility, and it is important to discuss the preliminary feasibility and to establish a progressive criteria to enable first trials in order to go step by step and in order to be realistic with a point of view on the future. This is the first important item. The second message, and it is very important to assess in advance if the involved operator has gained the necessary experience through the obtainment of at least one operation authorization in beyond the visual line of sight. This is very important because based on last 2 years' experience, in some cases, lack of operators' experience could lead to delay in the scheduled program, and we would like to avoid this. And a clear indication is given because in order to have a suitable experience, it is important that the drone operator has gained at least one operation authorization in specific category for flights from, for example, a location A to location B, far, for example, 5 kilometers, in scarcely populated area within segregated airspace by NOTAM. Today we do not have very much operator that has gained this authorization, and we encourage the new enterprise, the small and medium enterprise, to go ahead on this path, on this road, in order to show to ENAC and to public institutions that there are new offer from the enterprises. In this slide, we remark that the obtained of the relevant operation authorization, and on the right you have an example, may ensure that operator has gained sufficient experience to issue risk assessment and have sufficient skills and resources to show to ENAC compliance to the regulation and to give a contribution to the public institution. This is my last slide, and I thank you very much for your attention.
Thank you, Mr. Delisa. Thank you. I appreciate a lot the attention to the industry you are having in Italy and with your role. Thank you for this presenting what you are, as ENAC, Italian Civil Aviation Authority, is doing. Indeed, we all know that if you cannot fly, it's a responsibility of ENAC, but also if we fly, it's a responsibility of ENAC. So let's go to the next presentation. It's a pleasure for me to present Mr. Hari from the CESAR-JU. Yeah.
Yes, please. Can you? Thank you. Hello. Good morning. Thank you for inviting me to this event. Then my name is Cengiz Hari. I'm a program manager with CESAR-JU. I started in Eurocontrol 2010, and I'm with CESAR-JU for as of 2018. Previously, I was more with automation project, virtual center projects, and now for 2 years, I'm more with U-space related project and activities. I just always like to start with a funny picture. I like this one. Just to let you imagine that in the future, maybe it will be difficult to take a picture of a sunset without having black spots in the horizons. Maybe it's our fault. I apologize for that. Yes, yes, please. Can we please? Why, in the previous one, why CESAR-JU? Then here you see the current context. Everybody knows the current context. I will not go into detail. Then you have approximately 30,000 flights a day above the ECAC region. And in the future, again, if you are here, it means that you already know the context of the future aviation. I just would like to highlight just one sentence here. The digital economy will result in a radical transformation. In fact, this is what we are doing here. It's really the impact of all this digital revolution that was stemming around the world those last 20 years that is impacting, and it's one of the drivers where those U-space and drone technology is popping up. Is the quality okay with the mic?
If you take
Okay. Few words about CESAR-3GU. Then you know that we were CESAR-1. We moved to CESAR-2, which is CESAR 2020. And as of April this year, we are now CESAR-3. Some elements about CESAR-3, which is different from the previous one. The aim is to accelerate the delivery of a solution. It's one driver. In the previous one, we had 17, then 19 members. Now we are more than 50 members in CESAR-3. In terms of budget for the CESAR 3, then we have the Horizon Europe, no more Horizon 2020, it's Horizon Europe, 600 million. Eurocontrol contribution in the project, in kinds, mainly 500 million. Industry, also half a billion. And also, on top of that, we have a CINEA, which is the previous CEF involvement, which is injecting projects, injecting budget to deliver projects. I will give some more words on that also in the course of the presentation. CESAR is not only, it's not alone, it's a strong community. We are, everybody like to say, I'm in the middle of, okay, we are part of a lot of stakeholders. I will not go into detail, but if you are here from different entities and different sectors, public, private, industry, and so on, means that you are part of this community. The list of our members, 54, some of them will recognize themselves, then probably you are here in the list. Also, in the course of next year, we will open a call for associate members, because here the members are part of the European Commission. We'll open it for associate members like Switzerland or UK or other countries who want to participate. Okay, it's working. Thank you. Some more words about the CESAR 3 joint undertaking. Then where CESAR 3 is coming from. Then it's stemming from an initiative at the European Commission level. You all know about the single European sky that started in the middle of the 2000 period, defining the aviation strategy. Out of that aviation strategy, some main KPIs. Okay, here the figures are difficult to read. They set up the technological branch, the technological arm of the Single European Sky. It's CESAR, the Single European Sky ATM Research, CESAR, where we have a cluster of 2 entities, then CESAR Joint Undertaking and CESAR Deployment Manager. The Joint Undertaking is all the development and the master plan definition, and the deployment, it's SDM. Out of that, our Bible is the ATM Master Plan. And again, I repeat, maybe you know it, you don't know it, but voilà, I explained that. The master plan is there, which is the reference for the definition of all the current and future activities. Now, let's dig to some more details. Past, present, future. The past is on the top left side for you, which is all the project we did starting from 2017. Then what we call exploration phase. Then those are the 19 projects we did. And as a result of this, this is the CORUS. Then the CORUS, the first version. Here we are CORUS-XUAM, which is a continuation of the CORUS. The CORUS CONOPS H3, which is one of the masterpieces of the delivery of this batch program. Also a set of other documents, like the blueprint, like the architecture principles. All those are stemming from this project. Just before going to the next slide, I just wanted to make a parenthesis here. Who is born before 1970? In the room, who is born before 1970? Okay, what was your first computer? The first one. VIC-20. What was your first computer? This was my first computer. Then I was 12, ZX81. Then it was a 1K of memory. And when I see the first batch of project we did, 2017, 2019, reminds me that period of time. Okay, I was young, very young. And all these pieces, blocks, then you had the tape here. That it was not my tape, but the tapes on which I had U2 and Queen, and I used it to put my program. This is the kind of activities people did in the first batch of project. This is what we see exploration. We learn some elements and we move to the next level of maturity. Here we are in the second phase, this one, demonstration. This is the current set of projects, 17 projects, divided in mainly UAM related activities where the project CORUS-XUAM is embedded. Then you see, maybe it's a little bit too small, but we have a 6 VLD, CORUS-XUAM is one of the 6 VLD. We have Metropolis in this UM area. We have projects related to the ATM U-space interface, like PG34. We have also some older advanced services project like Icarus. Honestly, I suggest you to go and see the project results of the Icarus project, the Common Altitude Reference project, which is very big success. I had a meeting, sorry? Sorry. Icarus is a very good project. We had even a meeting Monday with EASA. We shared the results of the project with EASA, and they are very interested by the outcome of this project. Then just to see, voilà, I'm sharing the first results because we are at the end of the second batch. This batch of a project started 2020. Now, slowly, like today, we see the results of the CORUS Italian branch, but all the projects should end of 22 or early 23. And the first results are very, very promising. And this is what I call, let's say, maturity level number 2. It's not still the target. We are putting more and more a frame to go to the next steps, which is the second batch of computer I had the Dragon 32. And the computer side, you know what is the next one? The black one? Somebody knows? Amstrad or Schneider? And the machine was the CPC 664. It's premonitory, then EASA 664 rules, then I don't know, it was written in the stars. But voilà, this type of evolution, then I bought it 3 years after. You had the hard disk, you had memory, you had the colors, you had some protocols, RS-232, etc. Things are slowly setting up, but we are not there yet. Next. What is next? Then you know that, okay, those projects are terminating. We have a CESAR 3, and what is the framework for CESAR 3? Then this is a picture that is explaining the way we will work in CESAR 3. Again, on the left side, you see the ATM master plan. Out of that, we extracted what we call the SRIA, Strategic Research Innovation Agenda. Out of that, we have the annual working plan, and we submit regularly calls for projects. The type of projects, again, 3 types of projects: exploratory research, industrial research, and no more VLD, but DSD, the Digital Sky Demonstrators. The organization of the exploratory research is divided in 2. Then excellent science or application-oriented, industrial research. For the industrial research, you do not move anymore from V0 to V3. The aim is TRL3 to TRL6. And we have also on the below what we call the fast track. Then this was one of the lessons learned of the previous CESAR. It's a fast track moving from TRL2 to TRL7 in 3 years. And this is to be one of the challenges, and then apply the agile methodology. And again, the lessons learned from the digital world apply to the aviation. This box fast track innovation, not only the technology, but also the methodology of the digital world applied to aviation. Then DSD course. The DSD course, it's a little bit specific because it's funded via the budget allocated by CINEA. As far as the exploratory research and research, the IR are funded by Horizon Europe. Compared to CESAR 1, the main difference is on the right side. You see that on CESAR, the previous CESAR, we just deliver CESAR solution that is stemming to the CESAR solution catalog. Now it's not only that, it's really ready to be deployed solution that we have to put with the input to standards, input to regulation, but not only recommendation. Really need to have a document called STANT, a document called REC, that is the output. And the last one, I explained that it's accelerated market uptake and deployment. Voilà, then on below you see definition, development, deployment, the 3 phases, which is the main part of the future development. Means that this will trigger the 3rd batch of projects that are currently starting. Just for information, the Digital Sky Demonstrators that has been submitted last year, granted, the grant agreement preparation is currently in the signature next month for 3 U-space projects, demonstration projects. For okay, I cannot give the budgets here, but 3 projects will start in November, and I will explain also about the CESAR 3 project. But just to say that now we are moving from maturity level 1, maturity level 2. Okay, maturity level 3, you recall the PC 80, then the floppy disk 515. Okay, more and more maturity, but still you see the past. Then when we had the first computer, we're already imagining the future. This is what we are doing now. But all the protocol, the standards, the rules that we had at the time have evolved, and this is what will happen now. Then the current concept of operation, the concepts we are doing, is not the final one. It's just a step to go to the next one. This is the iterative approach that we have with this type of a batch project that we have. Just a reminder, 2 reminders, in fact, that there is currently a call ongoing that we submitted for a project with César. Okay, it's a short time. It was submitted in April, closure next month. I know that some of you are working hard to achieve the deadline. But for U-space related projects, I know that there is a bucket of 35 million with a maximum of 5 projects that will be allocated. And deadline 13th of October. And lastly, in fact, I didn't succeed to put in my slides because it was submitted yesterday. It's another call because now it's in LinkedIn, you can have a look. But again, there will be a new call for DSD for 2 areas, not U-space related, but still about gradual transition towards higher level of automation. Okay, name it. And the second batch of group of projects, it's virtual centers and ADSB, then ATM, data service provider, which is a continuation of current project, I think, managed by Leonardo. I think that's all for my presentation. Then I will be ready to reply any question you may have afterwards. Then thank you for listening to me.
Thank you, Mr. Ari. Thank you for this very fresh news you delivered here. And I would like just to underline one point of your presentation, that is the relevance and the research is focusing not only on technologies but also on methodologies, so procedures and processes. That is another relevant part. So next step is next speech is from Luigi Brucleri from INAV, Head of Research and Innovation. You all know how much effort is spending ENAV on this industrial domain.
Thank you, Antonio, and good morning, everyone. Just a second. I tried to remove some slides thanks to the nice presentation of the colleague so far, so I didn't introduce what urban air mobility is for INAV or what are the advantages of having urban air mobility for sustainability. I'm much more focusing my presentation on what ENAV is doing in order to achieve the deployment of urban air mobility, solutions for urban air mobility, and where we are deeply involved in this current period and what we are expecting. So thanks to the presentation, especially of César Geyou, we see that there are a lot of opportunities, co-financing opportunity in front of us in order to further mature solution and to be ready for good and excellent solution for the market. Of course, we have some priorities in the research as INAV. INAV is a big group, no? We have several companies, several. We can represent several stakeholders. They are navigation service provider. We have a drone operator. We have a U-space service provision. So we can be inside our company already, inside our group already. Need to create an ecosystem for this market. So it is a complex environment. We have, of course, to let balance the different viewpoints, the viewpoints of the air traffic controllers, the viewpoints of a company that have to have a business for drones, that in some cases are considered as a financial or business opportunity, in other cases a threat. No, so that's it is a challenge. We already have several meat on the fire. So we have already several projects that help us to investigate single aspects of this complex domain. We have several running projects and someone just closed project where we focus on this interface, U-space ATM. We have Aura project and Airpass in Air project, where we have as well the possibility to understand where remotely piloted aircraft or UAS in general can be integrated in air traffic control environment. Of course, CORUS-XUAM, that is our important demonstration that helped to focus on the flight development of U-space services. And we are expecting soon to start with a follow-up project that is much more focused on the market uptake, U-Welcome project. We have as well other research activities that are more vertical for the some use cases for drones, like Redox, as well with the Distretto Tecnologico Aerospaziale, where we have the possibility to fine-tune capability of tracking and flight planning of the operations. And we as well focus on cybersecurity and procedures for this Airpass maybe supported by GNSS and other capability, like respectively the project Cruise and Icaro. So that's just a high-level helicopter view. An helicopter view of what we are doing in research and innovation in order to pave the way for the deployment. We, of course, we are always and continuously monitoring scouting the business, co-financing opportunity, and Cesar 3, of course, is one of our key challenge, not to prepare a very suitable proposal in the coming weeks. And we believe that only with this such kind of approach, so cooperative research, we are able to demonstrate and to mature solution, especially for inter-USSP, where we need for sure having the possibility to cooperate with other country or with other company, and Welcome, we hope, will give us this concretely, and also to harmonize our development in a European way. So not giving too much complexity to drone operator that want to move from a country to another. That's the principles and objective we want to follow, and we put as a key objective in our research and innovation activities. So that's just a list of key topics of our research. Of course, as I said, the integration of Airpass in a controlled environment is one of the challenge. Advanced air mobility, urban air mobility is key, and we are here for this. The way to make shorter the path from laboratory solution and the market is really important, and interoperability in a more collaborative way between ATM and U-space is as well important. And then, of course, to give experience and to gain experience on use cases in order to customize our prototypes and then products according to the need of the operator. That's all from my side. I try to compensate a little bit. Thank you, everyone.
Thank you, Luigi. Thank you for this view of the ENAV group effort on this technology domain. Now we should have intervention from Mr. Curana, but due to very last minute commitment and problem, he was not able to stay with us. I know that Giancarlo may say some word about his role.
Yeah, with pleasure. Let's say, first of all, apologize from Munich not being able to be here because with the Director General he was attending another meeting. So, ubi maior minor cessat, we say in Italy, you know. So it's something that was happening. So, but anyway, just a few messages that were coming from us. Of course, Munich was going to sell few messages that we were agreeing together before coming. The main messages are mainly related to the activities we're already doing with the Italian partners. And so among one of these activities, of course, we are referring to the UM sandbox that INAC and some other Italian stakeholders are building in Fiumicino. So we will follow and we will support this activity, as well as we have the cooperation we had on the urban air mobility roadmap task force we did together. The idea is also to move forward, let's say, to have some activities developed in the vertiport environment. Of course, and this was the key message that Munish was going to sell to you. It is mainly that we have also something that is trying to help as much as possible the exploitation of what we are doing in all our research and innovation project, is the so-called EU network of U-space stakeholders that is co-chaired, let's say, by Eurocontrol, but it's mainly pushed forward by CESAR Joint Undertaking, European Commission, and EASA. Eurocontrol is mainly animating this fora, and we have there a lot of stakeholders that are participating. It's an additional fora where we are trying to come to common conclusion in the community, and so we look forward to have other members to join the, let's say, the community we are building on that. And very soon there will be some initiatives pushed forward by CESAR Joint Undertaking and the European Commission, and that I know by the end of this year, if I'm not wrong, Cengiz, we have also a workshop, a big workshop that will be organized by European Commission and CESAR Joint Undertaking to present the Drone 2.0 strategy. So take it into account, and these were the key messages that Munish was going to sell to you in case he was coming. So thank you very much, and enjoy the rest of the meeting, as we said already.
Thank you, Giancarlo. Indeed, we are also member of the European Network U-Space Stakeholder, and I think that it is really a very important community, and I participated in 3 or 4 meetings, and it was a very, very learning experience for me. Now, we have some spare time, so we can enjoy some coffee break. It arrived. They informed me that there is coffee break outside the room, so we can take some moments for networking and for discussing any specific point. We come back to start the second part of this meeting at 11:30. So please take 30 minutes of break. Sorry, everybody. It's time to restart. Please take your seat. If there is some person outside the room, they can be invited to come here. Now we have the meat of the meeting. So the session dedicated to the demonstration, to the development of the applications of the UTM and ATM systems and procedures and methodologies, and the demonstration we realized in Puglia, in Grottaglie and Manduria last June. So I guess it is the most important or the most interesting part as we are going to show you what we have achieved and what we learned. So Giovanni Riccardi is the first one. The floor is yours.
Maybe we can try with the mic again, or it's better that I stay here. Better that I stay here. So good morning. Thank you very much all the cameras today and also all the people that is watching on streaming online. So I'm Giovanni Riccardi from INAV, working for Research and Innovation, and I'm the task leader for this VP8, which is called the Italian demo, or better, the Italian job, let me say. So with this presentation, I will show you an overview of what we did in this demo that started, work that started during the pandemic. So it's, there is a lot of the work behind, because the very challenge was to put together people, systems, infrastructures, technologies. So today I will explain with this presentation an overview, a general overview of what we did. Then after, each colleague which was responsible for each operation will talk in detail about what we did. So, as also you look at on the presentation, or also on the brochure, the main scope of Italian demo was related to a safe transportation of a medical cargo from a civil airport, so a controlled infrastructure like the Taranto Grottaglie airport, to the city center, so near the city center. Of course, the main scope is to test urban air mobility operation in urban and suburban. Why suburban? Because we had a civil controlled airport, and we had a big aircraft that was able, fixed wing aircraft, that was able to start from a controlled airport. So with additional operation with small drones. So we try to put all together these elements in order to reach this target. Of course, this demonstration is in the frame of very large demonstration of SSR, and the main aspect that was targeted was, of course, technological and operational aspects, in addition to safety, access and equity, cybersecurity, and also human performance of the actors involved. Because we had air traffic controllers involved, we had pilots, we had operators. So we had specific assessment of this key performance area. The main aspect was related to the fact that we had an air traffic management and the U-space, which represent two sides of the same medal, let me say. So they are complementary, they need interoperability, and we tested this interoperability. So the scenario was represented by the first step, so a vaccine or medical goods that arrived at Taranto Grottaglie that was transported with a fixed wing aircraft with a pilot on board from civil airport to the Manduria airfield, the Aerotre. For a distance about 20 kilometers. In the meantime, we had also other drones that was operating in the meantime in the area, in the U-space, let me say, experimental areas and volumes for other operation, both photogrammetry, inspection, and so on. Coming back to the main operation, this medical cargo was then unpackaged and charged about on the Technosky drones. It was less than 25 kilos drones that were transported with the BVLOS mission, so an operation which where the pilot cannot see the drone with his eyes, but look at on the systems, on the cameras, and so on, for a mission about 6 kilometers from the Manduria airfield to the city center of Manduria. In all of this one, we also tested the last part. Was not the least, let me say, but it was to test how works the interface between air traffic management and U-space if there is an high priority operation that need to start from the control airport and execute the operation in U-space. So we also tested this aspect that also my colleague Emanuele will explain better after. So this was the scenario. As I said, it was represented also, we used an urban air mobility corridor, so a volume dedicated to the operation of the fixed wing aircraft of a pipistrelle vertical solution. The volumes indicated with pink, white, yellow, and orange are related to the volumes used by other drones for the operation under the corridor. And then from Manduria Airfield, Aerotre, to Manduria Hospital, we had the mission with the BVLOS operation for the last cargo med delivery. We had several, as I said before, one of the challenges was put in place all the actors, starting from the USP operator, so the U-space service provider help desk from the flight, the tower and ground controller from Grottaglie, because you know that Grottaglie is a civil airport with a control tower, so it's operative. Also, flight information service, the urban air mobility, the pilot of the big aircraft. We had also system like US the flight system, the airfield entity of Aerotre Manduria, INAV like a navigation service provider, ENAC like competent authorities for provision of authorization, of course, for BVLOS operation, and other drone pilots. So, just to give you an overview, what you will see after, here we have a picture of the systems and the vehicles used during this mission. We have a pipistrelle fixed wing cargo with pilot on board for the transportation from civil airport to Manduria Airfield. The TechnoSky US system that was adapted for transportation of a small cargo for BVLOS mission. It was a Nimbus drones operated and piloted by TechnoSky, which is official operator of INAV Group. With also participation of other drones from personal drones that was contributed with the small drones operation in the area of Grottaglie, the DTA also drone, because also DTA is an operator that joined to this demonstration. We have the system, the platform of the flight for the let me say, irrigation and of the services, U-space services to the people involved. We had also a system, a drone detecting system for detection of non-cooperative drones that was also tracked by the flight. Of course, the location that was composed by the Taranto Grottaglie Airport, the Manduria Airfield Aerotre, and also the Manduria City is an area near the hospital. This was an architecture, so it's the same picture that I showed before, just in form of diagram with connection between operators, navigation service provider, U-space service provider, experimental, which was the flight, the other operators, and also drones involved. Then I want to leave the floor to my colleague Emanuele Ficola, which is an air traffic controller from INAV, that was operational leader of this aspect with particular attention related to the part related to the ATM, air traffic management, so controlled airspace and U-space, because we, as I said before, we tested this interoperability in a methodology that we call the Italian job. So I asked to Emanuele to come here and make the presentation. Thank you very much.
Just before starting, Manuela, I remind that we have a question and answer session at the conclusion of this phase. So take your note and feel free to ask and to comment at the conclusion of this session. Please.
Good morning, everybody. And just Gianni said, I'm Emanuele Ficola, an air traffic controller from Rome Control. approach and area controller. So in the frame of Italian demonstration, we would like to demonstrate also that controller space and U-space are two sides of the same coin. They are complementary and they need technological and operational interoperability. So we can get a process called dynamic airspace reconfiguration. To do this, we simulate an high priority operational flight located in controller space that need to be executed in U-space. This trigger a coordination between ATM service unit and U-space service provider, and a relative exchange of information between the two sides. Now we see what happened on our simulation. As you can see on the screen, in the first step, the HEMS flight, the pilot of the HEMS flight called the air traffic controller and tell him all the information about the mission. The air traffic controller recognized that the target of the mission is located in U-space, and with the standard procedures call the D-Flight support desk, the U-space service provider, that act as a bridge between controller space and U-space. With his systems, they send a notification message to all the U-space users that, and they activate a response plan. So they land all and send back an acknowledge message to the flight support desk. He relayed the information at the ATC control tower, and the controller tell the pilot that the area is free of drones, is deactivated. So the mission can be done safely, in the safest way. At the end of the mission, we have the same process, but in opposite direction. So the pilot tells the air traffic controller that the mission is over. The controller relay the information at the D-Flight support desk that send a notification message to all the U-space users that can resume their own navigation. So we can get the dynamic airspace reconfiguration. Thank you for your attention.
Thank you, Emanuele. So this is the general view of the process of the mission scenarios and how it was managed by the relationship between ATM and UTM. Now the second presentation from Luigi Bruculeri from about the flight system.
Changing the head. So again, good morning everyone. Luigi Bruculeri, D-Flight this time. As a seconded in D-Flight, I'm dealing with the research and development activity in D-Flight. And I'm here to present you what is the U-space service solutions provided for this demo. That is, of course, considered very fruitful for maturing the way user can consume our services and to, of course, improve the usability and safety of these services. Regarding the first slide, I would like to recall the 4 mandatory services of the 664 regulation, so the network identification, traffic information, geo-awareness, and flight authorization. I don't want to enter too much in detail on this. I'm expecting all the audience well knows what these 4 services are, but quickly, of course, network identification in our case is the possibility to retrieve the information from the WAS operation to know who is and where is flying each of the operation. So this has been developed in different ways in our implementation. We validated, we had the possibility to have some boxes, Policino boxes, and we will see some drawing thanks to the, one of the partners involved in the experimentation, that is Top View. So we have a hook on device. In this case, they can be linked, attached on the drone itself. So independent on the device itself, it's a way to have a kind of retrofitting. We have a solution that are plugged in GCS, so there is a possibility to develop some possibility to acquire the telemetry of the drone and send this information to the flight. We have developed a dedicated app also as a possible way to attach with the DJI solutions that have some software development kit that allows the possibility to retrieve this information of telemetry. We have the networked direct remote ID antennas. So we have some coverage with some antennas that is able to detect the signal that drones emit, and then of course can be used to enrich in a different way the traffic information for drone operations. And of course, as I said before, there is a D-Flight app that provides us the possibility to simulate tracks and to enrich the traffic sample because of our objective to have a more complex air situation in the scenario. So there are hidden slides, so I go on this one directly. So traffic information, of course, collects all the received position and identity of drone operation and integrate with other manned traffic information that is retrieved with several ways. We manage to integrate with our the INAV set of information of surveillance. We have also some stream of some feed of ADS-B manned aviation by means of the flight aware, and so these integrate already some aerian coverage of ADS-B traffic. Of course, we have the possibility to use the same techniques of hook on device or manned, if possible. That is still a possibility. Regarding geo-awareness, we already have in operation some map of where to fly or not to fly in Italy. We are already have been mentioned in the Italian regulation as a place where to find the replica of geo-awareness. So where are the places where it's possible to fly or not fly in Italy? Of course, in this exercise, we developed some add-on in respect to the let me say the baseline operational map. So together with other way to represent U-space, airspace, and to distinguish with other volumes that are not U-space bubble. And we have a mechanism to have the planning of the operation, the acquiring of the flight authorization, and the activation of the operation itself. All the mechanism beyond the workflow of the flight authorization services. So not only a mechanism to plan and obtain the flight authorization, but also a mechanism to activate the flight in order to change, let me say, the status of the operation itself. Here in the map, you can see the drawing of the volumes as presented by Giovanni and Emanuele. Of course, we have essentially two core operations, but surrounded by other traffic that stimulate, and of course they are witnessing the other and collaborate according to the rules of U-space. So we have the first operation that is in this corridor here, and then the second one on Manduria. Of course, you can don't see my finger pointing. Maybe here like this. I don't know. No, another. Okay, but you can imagine according what has been described before where the two operations are. According to, this is a geo-awareness, so you can see that the DOP are inserted. The user can consult the map with all the constraints. of course, these are a reference for operation that are open, so a user that is approaching without any extra, let me say, authorization provided by the authority can look at the map and see what are the conditions of the airspace. In that case, of course, in the point where it is clicked, it's evident that you are at Grottaglie Airport in Taranto, and then, of course, it's a very critical area, and for this reason it is red on the map, and it is described that 0 meter is allowed. So it means that you cannot fly without instructing a request of a specific operation, providing all the evidence you can manage the risk to fly in this operation area, and of course asking with other modula ATM 09 blah 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 other processes the authorization to the authority that put the constraints on the airspace. In this case, of course, INAC and INAV, because it is a volume in an air traffic control area. That's the reason. Regarding back to the operation, of course, in the tactical phase, we have several operations running. We have other as well overlapping, and this, of course, can give warning to the operator, awareness of the operation, and so this traffic information is provided out to all the relevant operators flying in this volume of airspace. We as well described the dynamic airspace reconfiguration mechanism. So all the dialogue that has been ping-ponged in the presentation of Emanuele. We had, of course, the possibility to, in a flexible way, close portion of the U-space airspace of this experiment, showing this event to all the concerned actors. So we have, of course, this is an alert given when it is happening. So for whatever it is the reason, of course, for the flight is quite agnostic, of course, of the event. This, of course, can be triggered by an authority to give this change in the U-space configuration, providing the coordinates of the volume that can be removed from the U-space airspace because of a transit of an emergency flight as described. And so this is not anymore part of U-space airspace because it's given back to the ATC, that because of we are in a controlled area, it is happening. So I move up, not giving you again a beep.
You should have a slide before these ones that you skipped before from the Regia.
No, I don't know. Another one? Ah, okay. So maybe I went too quickly. Of course, in this slide, I wanted to show you that, of course, whatever it was, the way to communicate with the drone operation for network identification, we received, of course, with some difficulty, but there will be results at the end. We received the tracking of the operations, and of course, this was a really important exercise in order to have on the field the proof of and validating the technologies. So, of course, in the real world, there are several things happening, and I think we were lucky because happened. So this will be, of course, part of the results to make a synthesis of what we learned from this. Regarding last point, I guess, no, this one was, so here you can see, of course, the other operation, the one in the Manduria, starting from Manduria airfield to the Manduria center. Also, this has been a success. So also for this, we have the planning of the operation, the activation of the operation, and then the tracking along the trajectory of the flight. And of course, we managed to of course, monitor the operation during its flight. Last, here you can see some dynamics of the flight. last point, so as we said, we had also some network of antennas in order to detect drones operation. We had no operation in the volume of the airspace where we are, thanks God. So not cooperative one, thanks God, in the volume. But we spotted some operation, of course, on the city of Taranto. That's the reason why we draw you some slide with this operation. That's all. So this gives you a way to proceed. Of course, we used the other D-flight services for the pre-flight phase and to support the operation authorization process. The flight as well have maps that can be helping the preparation of the SORA, the preparation of the identification of the population density, the complexity of the map of the territory and so on, that are typically used by operator as well before U-space act from the flight perspective. So in the operation authorization part, that is a little bit earlier in respect to the U-space itself. Thank you.
Thank you, Luigi. Nice to see that projects are useful to develop solutions. Now it's my time. I will discuss about the other participants in the event, in the demonstration, because as you may understand or understood, there is not only the flight and a couple of drones, but we need also other actors to participate in these complex demonstration events. And this was the core activity of the Istituto Tecnologico Aerospaziale that I, Antonio Zilli, represent. So during these few slides, I will tell you about the Grottaglie airport test bed. I will tell you about the Aerotre airfield and about the Manduria urban land area, and actually in the last part about the secondary traffic we arranged during the demonstration. So let me start introducing who is the Istituto Tecnologico Aerospaziale. I understand there is persons that already know this company, but there is also persons that don't know. DTA is a no-profit making or consortium company with the mission to increase competitiveness of members and of other partners in the regional, national, and European aerospace value network. We work mainly on two main directions. The first one is aggregating and developing technology innovation capacity through national and international projects and through organizing events and organizing internationalization activities. And the other main activity is supporting public administration in understanding the industrial dynamic. Currently, we are participating or managing in several projects on the domain of UAS. The first site of the CORUS-XUAM demonstration is the Grottaglie airport test bed. It is a research and flight test infrastructure where we are a local system, but also national, and in this case, European partners can realize and exploit the infrastructure for flight test, but also for laboratory test. It is indeed equipped by us with other partners. The main one is Leonardo and Telespazio, but also other university and other local companies. They provided and they deployed the technological laboratories for simulation of UAS operation to ATM and U-space. Obviously, as the Grottaglie airport test bed is inside the airport, we have also the access to all the airport facilities and services, included a specific segregable airspace that cover a low population density area but also cover land, coast, and sea, and it is very important for who is developing the platform, but also the sensor to try to develop applications for analysis of data. Obviously, also other complex technological initiatives are ongoing, and you see some pictures that reflect some represent previous other projects. The laboratory, it is equipped with the data center, with the system to simulate UAS inside in ATM, and included human-in-the-loop configurations. It is obviously equipped, also available meeting rooms and control tower, and this laboratory is also was developed and exploited for others project, also for other, and we are planning to use also other CESAR project, in particular the Aura project. What we used, why this laboratory was useful to the CORUS, because first of all, it is a place where meetings were realized, but it is also a laboratory in which the UTM was available to the team, to the work group, so all the control of the operation was realized inside this laboratory. We had meetings, we had the systems available, and we had also the opportunity to survey and to add focused questionnaire to the operators inside the facility. The other component of this infrastructure that we use at the CORUS demonstration is also the control tower, because the ATM, the air traffic controller, was involved in the demonstration and did some activity. Obviously, as there is a real flight, other airport facility were exploited during the CORUS demonstration. Actually, in the airport, we are managing a garage hangar where the aircraft of Pipistrel company was hosted during the 3 days of the demonstration, but the airport offer also other more standard hangars where larger aircraft can be hosted. Actually, also the airspace was exploited during the demonstration, and all the services required to take off and landing of the Pipistrel aircraft was used. Actually, the airport facility was also the base of the other systems, included the UAS of the other partners, TechnoSky, and the other operators involved in the demonstration. The second site of the demonstration was the airfield Aerotre, which is, let me say, a standard airfield equipped with the hangars and the dirt runway. It is equipped also with a managed airspace. The runway is a grass runway of 400 meters length. And the main actions, the main activities they do is leisure flight, obviously, but also pilot education course. And the main motivation we exploited is not only the partnership we have with the managing company, but it is also quite near to the Manduria town, so there is also a logistic conditions. And actually we used exploited this airfield because of the runway that was used by the Pipistrel aircraft, but during the project we also deployed, let me say, experimental, very experimental vertiport with few minimal services provided by the power partners, GNSS augmentation system, obviously the energy provision, and an ad hoc area for the operator and pilot that was exploiting the system. In this airfield, what happened main, the first cargo flight landed, and the package was transferred from this first flight, the first operator to the pilot, to the second operator, that was Technosky in our case, and it was loaded, the small part was loaded on the UAS. And then the UAS take off, and after a route of about 6 kilometers, arrived to the Manduria landing point, that is an open air very near to the hospital, about 5 meters far from the hospital. It was selected due to the condition, very changing condition in those days. And at this point, we had the opportunity also to invite, after having confronted, after having meet stakeholders, in example, the director of the hospital and also the mayor of the town, we invited these stakeholders, external stakeholders, at the mission, and with the objective to assess the mission of the system. So we exploited the project not only to develop technologies and systems, but also to promote the capacity to realize mission with the UAS, and pushing the end users of urban air mobility services in starting thinking how UAS can be exploited. Indeed, in a couple of meetings we had with the director of the hospital, a number of potential scenarios was discussed and was highlighted, not only related to emergency and the urgency of transferring of logistic services, but also on low urgent operation, but very frequent, and maybe that can be more effectively be processed and planned. So it was very useful for pushing the development of urban air mobility concept that we are exploiting, we are better defining in other projects. So what how we used, exploited the open air inside the archaeological park Mura Messapiche of Manduria. It was the final landing point. It was the place in which, with the support of other project partners, evaluate the mission with the interview to the stakeholders, but also to the pilots, to the other project participants. And so we had also the opportunity to have some dissemination event connected with this place. During the operation, the main operation, we, as mentioned before, we had also secondary UAS traffic. It was realized in the rural area around Grottaglie, and it was operated by two actors. One was DTA, my company itself, with an Airfox 001 of 10 kilos of the mass at takeoff weight. And the second company was Personal Drone, a company from Lazio that joined the project with the 3 hire vehicles of different weights, and all of them flied during the demonstration. As you see the operation during the project. So what they provided is open category UAS operation during the main flight, and also they were serviced by the UTM flight. So they were connected with the UTM of the flight. They received information and they operated according to the information received from the UTM system. So as a summary, we involved all the operations. The demonstration of CORUS-XUAM project was related to 3 operating sites. All the companies involved in the managing of these sites were involved in the project activities in order to provide and participate and provide the facility. And we also involved other 4 external stakeholders in order to have requirements, in order to have mission evaluation, in order to have also direct participation inside during the demonstration. all of them were very interested in these kind of projects because they understood the innovation this project is bringing to society. So the experience was very satisfying for us. So that's all. And this is, you already see, is a picture of all the team involved during the demonstration, just for you to understand who we are. Thank you. I guess that the next one is, who is the next one, sorry? Is Alberto Favier from Pipistrel.
Good morning, everyone. My name is Alberto Favier. I'm a flight test engineer at Pipistrel. Pipistrel is a company with 30 years of experience on manned aviation. So for us, being involved in CORUS-XUAM was a great opportunity for the first time to get in touch with a manned operation, but also it was really important, I think, from the consortium to have the feedback of people, pilots, used to work in standard airspace. So this hybrid figure of us, I think it was really a interesting view, and my presentation will focus on our activity, so how we approached the scenarios and the demonstrations, and some lesson learned that as Pipistrel will bring on for the future projects. So as my colleagues anticipated, Pipistrel was mainly involved in the cargo delivery scenario. The scope of our flight was to simulate a medical good delivery through an unmanned vehicle, so for urban air mobility. Of course, this scenario was then converted into a test configuration, so a practical set of conditions. So to avoid complex flight authorizations, what we did is that we used a manned aircraft, a manned vehicle, to simulate unmanned flight. So what we did, we used all the practical aspects of manned aviation, interfacing still with the U-space and the UTM, making sure that our flight was still representative of an unmanned operation. So once we defined the scenario, there were 3 steps to follow to make sure that we could get to some useful conditions and representative conditions. So these 3 steps are listed here. So the first thing is that we registered into a U-space service provider, which is the flight. We defined a tracking method, so how our aircraft was tracked, the position and location was tracked in the space. And then the first step was mission planning and getting the authorization from the U-space service provider. So few words about our aircraft. The test aircraft was a Pipistrel Virus Shortwing 121, which is a type certified vehicle, 1 passenger, 1 pilot. It's a maximum takeoff mass of 600 kilos and is certified under EASA CS LSA. The aircraft is a really high performance, low drag. It can cruise really fast, up to 240 kilometers per hour. And basically really every operational altitude, so up to 21,000 feet, so 6,400 meters. Again, for pilots who are used to fly unmanned aviation, this is a standard configuration. There is nothing new. And let's see how we transform this manned vehicle into an unmanned operation. So step 1 was the registration on the U-space service provider platform, which is the flight. So as Pipistrel, we created a profile of an operator, and we created our fleet, listing our aircraft and getting a QR code necessary for the identification once the mission started. The second step was the definition of the tracking method. 3 possible methods were considered. The use of a UTM box Policino, which is an out-of-the-shelf product, typically used for small drones, but this is super convenient because it is light, is really not bulky, you can put it everywhere, and it works with 4G connection, so everywhere you have internet connection, you can get a good tracking. The second method was to use the pilot personal tablet through a connection on the flight. It was possible in flight with a normal tablet that everybody has to share the position between the pilot, directly the pilot, and the U-space service provider. And the third method considered was a really more refined one, so a data link, radio frequency data link connected to a ground control station. Among these three methods, two were selected: the UTM box Policino and the pilot tablet. Let's say that the third one was discarded first for implementation difficulties, but a lot of steps that were necessary for this implementation were actually performed. So we already implemented data exchange between a ground control station that Pipistrel has with the U-space, and this implementation will be super important in a future European project, U-Welcome, where all these technological advantages will be used again. So after we selected our tracking method, the last step was the definition of the mission. So we defined, let's see if I can show you here. Do you see it? Yes. So what we did is that we defined waypoints, GPS waypoints, between the departure airport and the destination airfield. And we selected altitude, we selected which aircraft, so our drone. We defined who were the pilots, and we loaded all the authorization that were necessary. And after we got the approval of the mission, as an operator, so a proper drone operator, we could start the mission. And as you see here, we could see our aircraft flying within the approved corridor. So this is to say the first scenario that we were involved. For us as manned aviator, it was really interesting to follow this experiment, and to be honest, was not incredibly critical, because flight plan is a task that is standard for manned aviation, and this process, as we see here, is pretty easy. A U-space service provider, the platform was user-friendly. The creation of the mission can be done with simple GPS points. So from this experience, we said, okay, a manned aviation can work with that, can understand this, and can, let's say, live together with this. The second scenario is the, let's say, takes into account a lot of the steps that we saw for the scenario one, but it included these, let's say, priority flight that for a certain moment prevented our flight to be performed. So again, priority volume was defined, preventing our pilots to work, to fly and take off. And as we saw together before, both the U-space service provider and the user, so the pilot, could see that there were a volume that was close to us, let's say, interfering with our planned mission. So again, this is pretty standard. No-flight zones are really understandable for pilots. So again, nothing critical, everything worked, and our feedback was just positive. So just few words to conclude and to show what Pipistrel learned. So again, for CORUS-XUAM, for Pipistrel was the first time where we were involved in unmanned operations, so a real flight test activity. So it was really important for us to get in touch with all the aspects of drone operations: pilot, authorization processes, U-space, tracking, so pure practical aspects. And then, since in the future Pipistrel will work on unmanned aviation, we are developing a drone, a vertical takeoff and landing cargo drone. It was important to have a first touch with U-space, U-space services, and U-space service providers. So, and again, in the future, Pipistrel will work on more and more on unmanned aviation. So as manufacturer, we will be involved again in these kind of activities, both in terms of flight test and in terms of supporting the operators. And at the same time, all the technology that was developed under this project will be useful for us in the future, especially in the upcoming EU project U-Welcome, where everything that we learned will be again made useful for the next step. And also, let's say, technology, meaning hardware and software pieces that were developed will be used again for validating U-space and U-space services in U-Welcome. So this is the end of my presentation. So if you have any question, we can get in touch later.
Okay,
Thanks.
thank you, Alberto. Yeah, indeed, took the opportunity to remind a question and answer session at the conclusion of the presentations. So next one is Michele Donofrio for TechnoSky.
Good morning, everyone. This is Michele Donofrio. I'm the drone project manager and the head of UAS department in TechnoSky. TechnoSky is an in-house group company responsible for managing and maintaining of all hardware, software, platform and systems used to deliver the air navigation services in Italy. And we manage and maintain 45 civil Italian airport, 44 radar systems, more than 200 navigational head systems, and more than 100 telecommunication centers across the Italian country. TechnoSky, since 2017, has also been certified by the Italian Civil Aviation Authority as drone operators for critical operations, mainly in the aeronautical domain. And since last year, we have also been certified to operate in beyond visual line of sight flight mode inside the airport environment, mainly for the navigational aid system inspection and the airport infrastructure monitoring and inspection. Regarding the involvement of TechnoSky in the CORUS-XUAM project, I want to spend a few words regarding the, let's say, the authorization process with the Italian regulator to obtain this important authorization to operate in beyond visual line of sight mode nearby the urban area. So, following the regulation by ENAC and issued by the European Commission related to the drone operations, the process as reported here as follows. And to obtain the authorization, we made an official request to ENAC to obtain an operational authorization in specific category, according the Article 12 of the European Regulation number 947/2019. After that, we also make a request of airspace reserve, compiling the form issued by ENAC, the form ATM 09, according the circular ATM 09 issued by ENAC. After the request, a project team has been appointed by ENAC, and ENAC has revised all the documentation to obtain this authorization. Mainly, we have developed the specific operation risk assessment, which is considered an acceptable means of compliance according to Article 11, the European Regulation 947/2019. And we have also developed the emergency response plan and the operation plan, reporting the normal procedures, the contingency and the emergency procedures according to the requirement defined by the European regulation. After all this process, we received some evidence, some comments by ENAC, and in 4 months we were able to obtain this important operational authorization that allow us to perform this kind of flight following the time plan defined in the CORUS-XUAM project. We have also need to give evidence to ENAC regarding the pilot competences. So we give evidence related to the remote pilot certification obtained by our resources, by our pilots. We give evidence of the skills related to the crew resource management and multi-crew cooperation, and also the competencies acquired in the SORA methodology. In the SORA, we describe the operating scenarios where we have used one of our drone is a multicopter developed by the Italian drone manufacturer Nimbus, and this multicopter is currently operative in Turin airport, where we have been authorized by INAC to operate in BVLOS to inspect the instrumental landing systems. And we adapt one of our drone in our fleet with a specific payload with the main object to transport the medical package according the objective defined in the CORUS-XUAM project. Here I briefly report some main technical specification regarding our drone. In this configuration for the CORUS project, we adopt a payload of 2 kilograms, and the maximum takeoff weight of the drone was about 17 kilograms with a wingspan of 1.8 meters. We have a wind resistance of 12 meters per second, a cruise speed of 12 meters per second, and in this configuration we use redundancies in the data link between the drone and the ground control station, using both the radio module and the LTE technology that allow us to increase the coverage and the reliability of the data link for all the duration of the mission. The endurance of the drone with this medical payload is less than 30 minutes, and I also reported the operating temperature and some other characteristic, because this mission can be performed manually or automatically, and in the CORUS we have performed this mission totally in an automatic mode. And we have also equipped the drone with some of the most safety devices available on the market, such as flight termination systems and also a parachute that can be activated both manually or automatically. So the operation, as I said before, object is a demonstration of air transport in beyond visual line of sight, performed by means of a remotely piloted aircraft. We have also defined the SORA in our operational scenarios, the flight profiles. So we were flying, we flew in daytime in BVLOS with a flight plan length of about 6,700 meters, and the maximum distance from the takeoff point and the landing point was about 6 kilometers. We adopt a maximum cruise speed no more than 10 meters per second, and the maximum altitude above ground level is 200 meters, and the max flight time to perform this automatic mission from the Aerotre airfield up to the archaeological site nearby the Manduria hospital was about less than 15 minutes. We also active the geofencing function and some other recovery function in case of data link loss, such as, for example, the return to home. So here in the screen you can see the flight trajectory that we have defined in our specific operation risk assessment, and as you can see, the takeoff point will take place in the Aerotre airfield of Manduria. After that, the drone has performed a climb up to the altitude of 200 meters above ground level, moving as on waypoint 1. From waypoint 1 up to waypoint 2, we perform 2 kilometers of route, and we overflew scarcely populated area and also an all-distance runway of the Italian Air Force. From waypoint 2 to waypoint 3, the yaw angle of the drone varied by about 30 degrees to allow a perpendicular crossing of a power line, and the trajectory continues up to waypoint 4, and finally on waypoint 5 nearby the urban center in Manduria. As you can see here, we didn't consider a direct line from the takeoff point and the landing point, This is due mainly to the need to define optimize a trajectory in terms of reduction of uninvolved people and to avoid to overfly in populated area where there are also buildings. So for safety reason, here we were able to reduce the ground risk. But considering the area, the operation has been carried out between two areas, the Aerotre heavy area and the a restricted area, the Romeo 405 Alpha, which is military area. And for this reason and to segregate all the corridor, we require the NOTAM that has been active for 2 days to allow us to perform this mission. Here in the screen I reported some images regarding the takeoff location. As I said before, the takeoff point was in Aerotre airfield, and the landing and delivery location was defined in the archaeological site. The park area is also bordered by fences, so during our mission we restricted this area, and in accordance with the director of the park, only authorized personnel was allowed to enter in the park, because of course the final phase of the mission for us was the most critical phase, because we reached a maximum distance of 6 kilometers, and the landing was not easy to perform. Being an experimental flight, we never tested these long distances before, and for this reason we tried to identify and be comply with all the operation safety objectives according the SORA methodology. So after all this process, we obtained finally the operational authorization released by the ENAC, and we were able to perform this flight according the time plan in June 2022. And here in this screen I reported some images regarding related to our mission. On the top of the screen you can see our drone when we are packaging the medical devices on board our drone. On the right you can see our ground control station, and below you can see the final approach and the landing area where we were able to recover safely the medical package. And I also report a short video related to the land of the drone after roughly 12 minutes of flight. And the mission was completed. And here, I didn't tell you at the beginning, I reported the process we have followed together with the flight, where we have uploaded our mission on the D-Flight platform, and after obtaining the authorization to reserve our corridor, we also installed on board our drone the UTM box Pollicino, and we were able to demonstrate that our drone was tracked real time for all the duration of the flight. So thank you for your attention.
Thank you, Michele. Another point that during this operation, we also had the opportunity to take note of some indicator in order to assess the quality of the activity and of the systems. So this is the topic of the next speech from Giuseppe Esposito from NICE.
Good morning, everyone. I am Giuseppe Esposito from NICE, and I'm involved in the CORUS-XUAM project dealing with KPA assessment for the Italian demo. The key performance areas addressed by the demonstration are human performance and safety. The analysis has been carried out considering specific metrics and indicators in order to address the demonstration objectives and the related success criteria gathered in the demo plan. For all the demo days, the analysis aimed at evaluating the perception of workload, situational awareness, teamwork and communication, operational safety, acceptability, and the adequacy of human-machine interface in supporting humans to complete their task and to collect information and feedback about the U-space services addressed by the demonstration. Quantitative and qualitative data have been collected by means of observation, questionnaires, debriefings, and systems data collection. The safety and human performance aspect have been assessed considering qualitative data. These data have been collected through observation, questionnaires, and debriefings. Questionnaires were submitted at the end of each flight to collect subjective data from all the actors involved regarding what they have experienced during the mission. The briefing sessions were performed at the end of each flight and in order to identify unknown or hidden safety and HP issues by stimulating open discussion and free opinion exchange among participants. Observations were recorded by the validation team and assessment experts during measured flight. Post-flight questionnaires were submitted at the end of each flight. We have prepared customized questionnaire for controllers, pilots or drone operators, and support desk. In each questionnaire, there were open questions, ad hoc open questions regarding the metrics and U-space services. And we used two scales to collect the feedback, an agreement scale from strongly agree to strongly disagree, and a frequency one from never to always. Participants have also the opportunity to add and to provide additional comments in a specific section at the end of each questionnaire. A post-demo questionnaire was filled just once at the end of the demo days to collect a global opinion and feedback on the whole demonstrations. Also in this case, we have prepared customized questionnaire for the three actors involved, but in this case, some indicators have been assessed using specific tools. The Bedford scale has been applied to identify the actor's pair mental capacity and workload in completing a task. The situational awareness has been assessed using China Lakes, and acceptability has been evaluated using controller acceptance rating scales. Also in this case, there were open questions considering agreement and frequency scales. That's all from my side. Thank you for your attention. Now I leave the floor to Giovanni for the preliminary results.
Okay. Thank you. And now, the last part.
Okay, so I will show you some first findings and results that we collected, as you said also from the other colleagues that talked before me. We got interesting inputs and outputs, of course, useful for the future activities and of course of the CORUS-XUAM project at all. So we had can you see it on the screen? Okay. So I collected here in form of a bullet several statements for recommendation and results relating operational aspects and technological aspects and also regulatory aspects. Of course, we noted that the strategic phase is something that is fundamental, is a basement. It can be seen as the column for the safe and coordinated and efficient urban air mobility operation. Of course, when I talk about the strategic phase, I talk about the use of authorization process, mission plan, NOTAM endorsement, and so on. So this was something that is represent the base, and then we have the tactical phase, which is based on what we did in the strategic phase. So a good strategic phase is fundamental for a good urban air mobility. The second aspect is a technological aspect, was related to the coverage of the 4G signal. We, of course, noted that near the city center, the coverage that you also have on your smartphone is very good. Not very good in the suburban rural area. This could be an issue because several times we lost the tracking for both the Pollicino, which was the system you can on device, and also with the D-Flight app. We noted this with the vehicle of Pipistrel that started from Grottaglie, so in a suburban area, and flown for 20 kilometers to Aerotre. Of course, we noted that several times we lost the signal of 4G. And this could be a possible issue. But the recommendation is to also look at other systems for the conspicuity, for the tracking of this kind of drones and vehicles outside from the urban area, in the suburban area. Also looking at systems like ADS-B or transponder that use different means of communication. So. We also had on the D-Flight the possibility to have the output from ADS-B signal, so all equipped aircraft with ADS-B can be visible and tracked also on the flight. So this could be a recommendation in terms of traceability, tracking of this kind of aircraft for operation, as I said, in suburban area. In addition, it was very important, also as underlined by Michele before, that during the landing phase of the near the city hospital, we lost the C2 link between the remote pilot station that was placed at 7 kilometers and the drone. So it was very useful to switch on the backup system that was, of course, based on the use of 4G. That the signal was good in the city, so the operation was carried out in a safe way, switching the communication channel. So it was very useful using this kind of a redundancy system, because consider that for BVLOS operation, the problem of different aids between the aircraft and also the location of the pilot or location of the station could be an issue that can be taken into account in the SORA process, and we did it. Another problem, another issues, another important aspect is related to weather information and weather in general, because meteo, of course, is something that is predictable, but it's very variable, in particular at local level. So it was very important for us to have punctual meteo information for the starting point and the ending point of the drone mission, because of course you know that wind and rain can create a bad influence on the flight of small drones. So we had this kind of information shared with the flight in a very punctual way, using also meteo radar, so information coming from the meteo radar that was shared on the web and used in order to understand the movement of clouds, the movements of the rain. So another information that is very useful is to provide to the user is a punctual meteo information. So we had also meteo observer, no? So human actor in both landing site and departure site that with the telephone providing information in real time. So, regarding the procedure for the coordination between air traffic management and U-space and management of some operation like emergency, priority flight originated in the controlled airspace and executed in the U-space, we proved that dynamic airspace reconfiguration was a very and valid and efficient means to manage it. So it's very important to stress and to work on dynamic airspace reconfiguration in the future projects. And I know that on CESAR 3, we had several proposals that we are investigating related to the applications of the DAR services in DAR service in U-space. Of course, some recommendation regarding the general approach that is important to give to the community, to the people, is related to the spread, the information, communication. What about is U-space? What are the drones, the urban? What is the urban air mobility? And spread this information among pilot associations, drone pilots, general aviation community, and so on. This is a must because people does know on what they were to face off today and in the next years. Also, some recommendation about sort of a simplification or automation in support to Civil Aviation Authority for the SORA process. Of course, is a fact of a number. If today we have to manage, they have to manage 10 SORA is something. If they have to manage 100 of SORA, is something different. So some automation or also tool that can facilitate and provide effort to help the Civil Aviation Authority is something good on which we could, of course, think about. Of course, many HMI improvements, so related to the interface between the pilots and the flight and the systems, were collected, of course, related to signals, to alarms, to sounds, in particular in the application of dynamic airspace reconfiguration. We got several feedback from the pilot, which are the users, which are the people that have to use the flight, which have to use this system from them in terms of visualization of information on device. So it was very interesting for us and for the flight to collect this kind of information. Warning message, visual and acoustic, was something that was, of course, addressed and assessed during the human performance assessment that NICE did. So these and in all from my side regarding the results, of course, these are preliminary impression and findings. We are writing the demonstration report, so when it will be published, you will have full access to the results of the whole validation activities, demonstration activities in the frame of CORUS-XUAM project. So now, if you want to see a video, it's movie time. So I'll show you the video that we produced that give you an overview of all the words that we spent today. So Antonio, if you want to show.
CORUS-XUAM is a CESAR 2020 very large demonstration project that is looking at how U-space services could support integrated urban air mobility flight operations, allowing manned and unmanned airspace users to operate safely and securely in a controlled and fully integrated airspace without undue impact on operations currently managed by air traffic management.
The Italian demo is one of the pieces of the CORUS-XUAM puzzle. The demonstration is focused on urban air mobility operation between two logistics centers. The demo involves a fast cargo fixed wing, piloted aircraft and other drones for specific operations, allowing the involvement of air traffic management and U-space component, useful to demonstrate coordination for management of urban air mobility traffic. Interoperability, automation are the keys for enabling the urban air mobility in a safe and efficient way.
The demonstration scenarios involve several nodes in the area around the Grottaglie Airport test bed. That is an open-air, user-friendly UAS flight test facility. The Grottaglie Airport test bed is the central hub. A large package starts its trip in a fast aircraft toward the urban hub. The airfield Aerotre quite near to the city of Manduria, emulates the urban hub. The large package is distributed in a number of small UAS.
The flight is here together with INAV and Tecnosky and DT Apulia and Pipistrel, NICE and Eurocontrol in the frame of the CORUS-XUAM project, CESAR project for the concept of operation of the European U-space services and extending them to urban air mobility. The flight is here as the U-space service provider, and with our applications we are supporting the fly of the drones in the airspace in the nearby the airport of Taranto Grottaglie in a safe manner, fully coordinated with the air traffic control and with a full situation awareness that is provided through our services, showing all the traffic that is moving around the airport, including manned, unmanned, sport aviation and general aviation traffic that is visible through our extended and modular network remote identification system.
The sky is to be considered a real strategic infrastructure, not only for traditional air transport, but for all the various services that interest different airspace. Controlled airspace and U-space represents two sides of the same coin. They are complementary and require operational and technological interoperability. In the frame of Italian demo, we'll demonstrate also a high priority operation of a flight originated in controlled airspace that need to be executed in U-space. This triggered the coordination between air traffic service unit and U-space service provider and related exchange of information between the two sides.
Being a partner of CORUS-XUAM is an incredible opportunity for Pipistrel. From one side, we can collaborate in the development of those services that will enable UAS, including the drones that Pipistrel is developing. From the other side, we can learn how drone operations will affect the airspace and the procedures for general aviation pilots. Indeed, urban air mobility is an opportunity for both manned and unmanned aviation, and this demonstration is a chance to test the coming future.
Tecnosky, as drone operator, is involved in CORUS-XUAM project for the last mile delivery of medical cargo. We are going to operate a mission in beyond visual line of sight mode. We will take off at Manduria airfield and we will land in Manduria city hospital area, performing a route about of 7 kilometers, maintaining an altitude of 200 meters above ground level and a cruise speed of 20 knots.
Within CORUS-XUAM Italian demo, the assessment will be performed considering specific KPIs, namely human performances, safety and security. Data will be gathered by means of questionnaires in order to address the demonstration objective and related success criteria set in the demo plan. The assessment will be conducted in accordance to CESAR methodologies.
Personal Drones is very happy and proud to be part of this project. We strongly think that urban air mobility is the future of transportation, both for people and for goods. Cities are complex scenarios, so it's very important to find the safest and the most efficient way to develop these new opportunities. In our opinion, one of the key points is to achieve a high level on coordination and integration with the other unmanned aircraft and with daily human activities.
So, this was the video. So, let me just adding a couple of words before to starting the question and answer session. I want to thank all the participants. It was very challenging, as I said before, because we merged a lot of people, infrastructures, ideas that is something that I think is the core of the innovation of the research. And thanks to Cesar JU and to founding and the co-founding of these kind of initiatives, we could bring something that, of course, will be the near future, and of course the next future. So thanks again to all the participants.
Okay, thank you. So you had also the chance to see that the weather conditions during the demo day was not the best one. And so now it's time for any kind of questions and curiosity you can have. This is not so formal, so feel free to raise your hand and propose observation, comments, and whatever.
Also, if you have a funny question, because we started this project 2 years ago in the full pandemic, and our idea was to bring a vaccine with an aircraft named the Virus, because so it started with something that was not very funny at the beginning, but with the excursus of what we had, we can make a smile on this small event. Yes, question? Yeah. We can listen to you better.
I would like to give you the microphone, but I guess that it doesn't work.
So you mentioned that a simplification of the SORA process would simplify the operation. So my question is, what are the main challenges that you faced in carrying out the SORA process? What do you think are the improvements, and other than the automation? And what the CORUS project did to help the authorities in noticing the problem, and if you already proposed some action?
Of course, I'll try to, thank you for the question. I'll try to answer, but we can forward also the question to the civil authority that can answer better than me. So the idea is not simplify the SORA process, because the SORA process is based on a process which, of course, need to ensure the safety operation, which is the first, of course, and the first statement, so safety first. So the idea is to provide some helps in terms of automation in the sub-emission process and the simplification just in terms of bureaucracy, let me say. Just an example that I give you. In Italy, we have something that is called PEC, which is a mail, certified mail, of course, when you can communicate with the civil aviation authorities, and it's a process that in Italy is stated, is famous, and is common. In a future environment, when we will have an European, let me say, look at, so an European picture, we could have several operators from different countries that can operate in other countries. So, of course, with the help of EASA, we have, of course, to continue to working to an harmonization of the process. If you are an operator from outside of Italy and you want to apply for a SORA, you need a PEC, and outside from the Italy, you don't have a PEC. So, just to give you an example. So, I know that also other activities in the frame of research, also in CESAR, are providing helps to SORA process. I know that the Blue Euro-USC are working to some specific tool in order to provide more automation in that sense. Of course, the idea is to help the regulator, because you know that the regulator is made by people. And people could sometimes could be few allocated on an activity, but the SORAs could be very high, a lot of SORAs to manage. So something that we could improve is something that could give to users more access, easy access to the operations.
From the output we did for the first batch of project. And now we are regularly with them demonstration that you had with them regularly, National Authority and EASA, not only this VLV but other VLV. EASA, in the coming months, weeks, I hope, they are discussing to change a little bit the severity of the sail level. If you have a European project or if you have a national funded project, if you are doing demonstration during a set of hours in a certain context, they will planning to reduce the sail level from 3 to 2, for instance, to allow demonstration and learn this type of demonstration where indeed a little bit harsh in terms of documentation to be provided to have authorization to fly them. This is already a short iteration, but the main is to have a longer iteration and adapt the regulation accordingly.
Thank you, Chenji. Totally correct. It's one of the pillars of CESAR, so to have the results and use the results for recommendation to regular authorities and so on. And consider that if we look at the history from the starting of the SORA process to today, we got several steps also in providing specific common scenarios published when the fact that if you have to conduct a specific operation and you are inside the scenario, the process is simplified. So this is a big step from the beginning, but we have to continue to work in terms of recommendation with the research project in order to enforce and help the regulation authorities, EASA, ICAO, and so on to manage and provide next regulation.
Sora, and the side trick is it was more showed more with risk higher than, but there could be also the opposite case that in some cases we consider some operation and the result of the automation is low risk.
Yeah, this is the problem of automation in general. So we need to collect the requirements for all the users and from the regulators in order to provide the best tool, let me say. So it's a problem of all the process that need automation. So thank you very much for clarification.
Any more questions, comments, observation? Please.
Yes. Okay, as also Emanuele showed in his presentation, the information is triggered from of course, from air traffic management, because there is the controller in the tower that need to start the HEMS operation and call by phone the support desk of the flight. Pass the information, a support desk of the flight, operational support desk, acts on the, of course, on the platform of the flight, and from the platform of the flight, the message is forwarded to all the users that has a mission. Of course, so the pilots receive on their display the alarm that and the indication to apply the emergency response plan. So in this case, land. So they landed after the message. They landed all the drones. Then the operation was executed, and at the end of HEMS, they got the message that they can resume the navigation. This is something that today is done by a human actor that acts as a bridge between the two worlds, because we call this, we have a procedure in Italy established, but the future is to act through the common information service and common information service provider through interoperability aspects between the ATM and U-space, and it's something that we are doing on Project 54 Aura.
Any more points? Please. Can you...
Please, come here. Come here, yeah. Yes. Yes, of course, you are saying something that is very interesting for urban air mobility. We have to look at also general aviation public, general aviation pilots. Of course, they are users, sports flight, VDS, they are users of very low level airspace. So they could take benefits from using a system like information that coming from a U-space service provider. So, of course, be conspicuous and look at the traffic that you have around, drone traffic, but also other general aviation traffic, is something that improve your the pilot's situational awareness. So, general aviation users will be also future users of U-space, let me say.